We have been performing different integration techniques, and there's a scenario whereby we need to use this method that is known as integration by parts. And integration by parts formula is actually this formula that we're going to be putting in place. The first thing that I need to bring to your attention, because you are going to decide what's going to be your U and what's going to your V in this integration by parts. And if you're not going to make a wise choice, you may end up getting into trouble. So in order to decide what your U is, in order to know what your U is, we're going to use this acronym that means called LIPET. LIPET, L stands for natural logs, stands for logs. Yeah, can be logarithms. If you see a logarithm, if you see a natural log in your expression that you want to integrate, you can be able to uh, assign it to be U. And if you see um, inverse trig, appearing first there, you are going to assign it as U. If you see a polynomial, you can assign it as what? As U. If you see an exponent, you can be able to assign it as U. And if you see a trigonometry, you can assign it to. What do I mean? If you are having an integral of ln of x over x, you see we are having integral of ln of x, and then we are having 1 over what? X. We are having two functions here, right? We are having natural log and we are having a polynomial, okay? So which one comes first in LIPET? Log comes first. So you are going to say that your u is equals to what? Is equals to your u is going to be equals to what? ln of x, right? So basically that's what we mean in order to learn this technique of integration by parts. So we are going to focus on two examples. We are going to focus on some of the kind of questions that you're gonna look at. So we are saying you are having question one here, and question one says integrate what? Integrate x e is to x, right? With respect to x. This is one of the questions that we're going to integrate by parts. And when you're integrating by parts, this table is going to be very important for us. So we are going to have a table that looks like this. And in one part, we are going to say this is u, and then this one is going to be dv, okay? Then here we shall have du, and then we're having here v at this given point. So using LIPET on this, we can be able to see we have a polynomial. A polynomial is those terms with powers of x. The power of x here is 1. We have a polynomial, we have exponents. Now, between a polynomial and an exponent, which one comes first? A polynomial comes first. So which will mean that in our integration here, we are going to assign u to be x, but the remaining e is to power x is going to be our dv. E is to x will be our dv. So LIPET enables you to identify u, and the remaining expression is going to become what? Our dv. Now, with x, what is du? Because if you are having u is equals to x, what will be du? Du is going to be 1 dx. If you differentiate x, you are going to get 1 dx. And if you integrate this, you are going to get the same expression there, right? So once you've identified that, remember the formula says what? If you're integrating this, It will be uv. What's your u? Your u is x. Your v is what? E is to x. So we can say x, because our u is x and our v is ex, so we shall say x like that, minus integral of v. What is our v? E is to x. Then we say what? Du. Okay? What's your dv? Then this part here, we are going to multiply. So this is going to be what? This is going to be integral of x e is to x dx is going to be equals to x ex. If I multiply this and this, I'm going to get x ex. And then since I'm multiplying now diagonally, I'm going to subtract. I'm going to do what? To subtract. Okay? So meaning that I will subtract integral of what? E is to x times this is going to become e is to x dx, because that is e is to x times 1 will be e is to x, and then we are having dx like that. So once you've done that, you can see we are having x is to x minus this, but integrating this now, this you see it started with two terms here. Now the term we are having here is 1, so we can be able to integrate this. Integrating an exponent of x, it becomes just an exponent of x, then we shall say plus c, like that. And we are done. So let us see how you can be able to perform this other one. This other one says you are integrating, question number 2, you are integrating x, right? X squared sine x dx. X squared sine x dx. So I want you to tell me, what are you going to assign as your d, and what are you going to assign as your u, and what are you going to assign as your dv? So our u will be what? Our dv will be what? We said we are going to use Lipet. We have a polynomial here, we have a trigonometric function here. So between these polynomial and trigonometric function, which one comes first on the term Lipet? Yes, we can say the polynomial comes earlier than the trig function. So we can say our polynomial, our u is going to be x raised to power 2, and then our dv will be sine of what? Sine of x, right? Now, once we have done that, of course, we can be able to, okay, in order to, we are going to do what? We are going to find dv, or rather, we are going to find du. Differentiating this, we are going to get du is going to be 2x dx. Integrating, because here we are having dv, we shall be going to v, we are going to integrate that. If you integrate this, what are you going to get? You are going to get negative cos x. Yeah, negative of cos x. And we say that we are going to, on this point here, we are going to multiply across, and we're going to say that this integral of x squared sine x dx is going to be equal, multiplying across, we're going to get x squared negative cos x minus, because we shall be multiplying now diagonally here, it will be negative, and we take the negative out, so that will be negative cos x 2x, because this is 2x and this is negative, so it will be negative 2x cos x dx, like that. So if I take this negative out, I'm going to have a positive value there, and this expression will reduce to negative x squared cos x plus integral of 2x cos x dx. So that is integration by parts. We cannot be able to stop there. Let me just write this properly. This is cos x dx. So you can see again this part that we are having here need to be integrated by parts. There's no way, there's no technique you can be able to use unless you use integration by parts again here. So let us integrate this term. So integrating this term again is 2x cos x dx. Now, again using lippet, we are going to identify, we shall identify again what could be our u and what could be our dv. We have a trigonometric function and we have a trigonometric function and we have a polynomial. So which will mean also we are going to take our u be equal to 2x, our dv will be what? Cos x. Now with that, we are going to find du here. What will be du? If we differentiate this part, what are we going to have? If we differentiate this part here, we are going to have du is equals to 2 dx, because if you differentiate 2x, you are going to get 2, and integrating this, we are going to get our v being equivalent to sine x. Then normally when we are doing that, of course, what we are going to say is that we are going to multiply across like that, and now our integral, which is 2x cos x dx, will become what? Multiplying this and this, it will be 2x sine x, 2x sine x minus, because we are multiplying diagonally, we subtract. So it will be this times this, it will be integral of minus integral of 2 sine x dx. 2 sine x dx as our term at this given point. Then of course we cannot stop there, because we are going to have 2x sine x. Integrating this, it's going to reduce to what? It's going to reduce to, because we are having minus, integrating this term that we are having inside here, integrating a sine, we are going to get a negative cosine. So it will be finally plus 2 cos x, then plus c. So which means that this integral that we were having at this point can be replaced with this part there. Then which will mean our final answer for this particular question will translate what? Minus x squared cos x plus 2x sine x plus 2 cos x plus c as the final integral of this particular part of this question that we are having. Questions which are we are going to integrate forever, like a question that will never end, but we can be able to integrate it the whole day. And this kind of integral is an integral like this one. Let me just show you this integral I'm talking about. You are given an integral of e is to x cos x with respect to x. This integration you can be able to perform the whole day without ending. But I'm going to show you the easy way you can be able to do it by integration by parts. We have an exponent, we have a trigonometric function. Which one comes faster? We have the exponent coming earlier here. So, which means that we are going to say that in our integration, we are going to say that our u is going to be equals to e is to x. And our dv is going to be what? Cos x, right? Now, once we have u and dv, of course, we say that we shall find the u. differentiating an exponent, you get the same thing, exponent. Integrating cos x to get to sine, it will be actually v is going to be equals to sine x. Then what do we say? Whenever you are using integration by parts with this table, we don't even need to remember the formula, because the integral of e is to x, cos x with respect to x is going to be what? You are going to say it's equals to, you shall multiply across like that. So long as your table you have rearranged it the way you have arranged it here. So you are going to say the answer here will be this and this, it will be e is to x sine of x. Then since you are multiplying now diagonally, we shall subtract and say that will be the integral of e is to x sine x with respect to x. So meaning that we have multiplied this and this, and then we have said with respect to x, because at this point, when you do du, you are going to get du, you are going to get e is to what? Dx like that. It has to be indicated there. Then, again, you can see the integral that we are having at this point cannot be performed by any other method other than integration by parts. So we are going again to perform this integral alone without looking at the rest. Let's perform this one integral by parts again so that we can be able to replace the answer that we shall have here. And that's going to be integral of e is to x sine x dx. Remember, we are going to have u and what? Dv. So this is exponent comes earlier, so we are going to say e is to x here. Du is going to be what? E is to x d what? Dx. And dv, because our e is to x became our u, this one becomes dv. So this is going to be sin x. Integrating this, we're going to get v is equals to negative cos x. Then, as we said, we are going to multiply across and then multiply diagonally. So our expression here that we are talking about will become what? Will become integral of e is to x sine x will, with respect to x, will become multiplying across, it will be e is to x negative, of course, because of this negative sign here, cos x. Diagonally, we shall subtract this, and this will be integral of negative e is to x cos x with respect to x. Okay, then we shall say plus c. All right, because we were integrating, isn't it? Then this is exactly what we were having. We need to do the substitution. So anywhere we are going to have this part, which is basically this one, we are going to replace that with this part that we have. So which will mean that this is going to be what? This is going to reduce to integral of e is integral of e is to x cos x dx is going to be equals to e is to x sin x minus, in bracket, this part that we have here became this. So it's going to be minus e is to x cos x plus e is to x plus integral of e is to x x cos x. Yeah, then we shall say plus c. We can even write it inside here. So then plus c, we can write it there. Then if we open the brackets, if we open the brackets, we are going to take this term and this term, because this times this will be minus. This is a minus and this is a plus. So this times this is going to give us a negative. So if we take this term on the other side of this equal sign, they are going to be two integrals of e is to x cos x dx. So meaning that we shall have two integrals of e is to x cos x with respect to x, which is equals to what? Which is equals to which is equals to e is to x sin x plus, because this and this will be plus, plus e is to x cos x, then we shall say plus c. Because it's a constant, we don't know which type of constant it is, you just say plus c. If somebody I know you start arguing that if this is a negative and this is a minus c, this is a positive c, then should be minus c. No. Because they're constant which we don't know, we just say because we are integrating, then plus c. If it's a negative, it will just come out at the end of the day if we were given the limit. And of course, finally, we can be able to say this integral reduces to x cos x dx is equals to 1 over 2 e x sin x plus 1 over 2 is to yeah, plus 1 over 2 is to x cos x, then plus c. Then plus c. Somebody may start arguing that so if we divided by 2 all true, also c will have to be divided by 2. But what I'm insisting and maintaining is that this is a constant. So at the end of the day, we are not going to put a half on that constant, because even if you put c over 2, is also a constant. Now, in order to perform also this integration, of course, we are going to use integration by parts. It's ln over 2x dx. But something that you need to remember is that here we have a 1 that is not indicated here. The one that we're having at this point is just the placeholder. So it means that in Lipet, we are going to take our exponents as ln over 2x as the value of u, and our dv here is going to be our 1. dv is going to be our 1. So meaning if we are going to find the u here, differentiating this, remember if you are finding d of dx of ln f of x is usually derivative of f of x divided by f of x, right? Remember that. You differentiate the function that you are having here, divide by that particular function. So basically differentiating this part that we have here, we are going to have what? We are going to have 2, and dividing by 2x, you can see now is going to translate to 1 over x, right? And then integrating this, we're going to get our v equals to x at that point. So we are going now to multiply this and then multiply diagonally, and we said that if you were integrating integral of ln of 2x with respect to x, this is going to translate to x ln of 2x. Then multiplying here, we shall subtract. So multiplying this and this, we're going to have integral of subtract, because we said when we're multiplying the diagonal, we shall subtract it, and that will be 2 over 2x times, remember we're multiplying this and this, times x, then with respect to x. X and x will cancel out. This and this will be 1. So this becomes x ln of 2x integral of 1 dx. Okay, integrating 1, what do you get? You're going to get x. So it will be x ln of 2x minus x, then we shall say plus c. And this becomes the final answer for that particular question. Sometimes you may be required to work out this kind of integrations, whereby you can be able to use integration by parts. You can be able to use integration by parts, but I want to show you how you can be able to use tabular method in order to perform this integration. So the first thing that you need to identify is that we are going to have a table, hence the name tabular. On one part, we are going to have derivative, where you are going to do the derivative, and the other part where you are going to perform integration. And where you are going to perform the derivative is the part which is a polynomial. So this is where you perform the derivative, and this other end you'll be performing an integration. So we shall start with x squared, right? We shall start with x squared, and the next part we shall have here we shall start with positive x squared. We shall be also alternating the signs, and here we shall begin with cos 4x. Now, if you find the derivative of this, we are going to say this will be minus 2x. Finding the derivative of this, we shall say plus 2. Finding the derivative of plus 2, you are going to get 0. So you shall stop there. Here you are going to perform integration. Integrating this part, we are going to get 4 integrating this part, we are going to get 1 over 4 sine 4x. Integrating this part, we are going to get minus 1 over 16 cos 4x. Integrating this part, we are going to get minus. All right, performing this integration here, we are going to have negative 1 over 64 sine 4x. So you shall multiply this direct like that. This one multiply to this, and this one multiply to that. So we shall say, therefore, this integral that we were having here, integral of x power 2 cos 4x with respect to x becomes 1 over 4, because if we multiply this and this, it will be 1 over 4x squared sine 4x. This time this will be minus, because this is a minus times a minus, it will be positive. So it will be 1 over 8 x cos 4x. This times this, for this is a negative here, it will be minus, and that will be minus 1 over 32 sine 4x, and then you shall say plus c. Basically, that's how you use tabular method. Let me also show you this one. We have a table. What you are going to do to find the derivative will be the polynomial, and what you're going to integrate is this other part. So which will mean that we shall start with x squared, and we shall have sine x. Then differentiating this, of course, we start with a positive. Differentiating this, we shall get 2x. We shall have a negative number, because it has nothing to do with this derivative we were doing, but we keep on alternating the signs. And then differentiating this now, we shall say positive 2. Differentiating a constant, you are going to get 0. You stop there. But this one, integrating this, we're going to get negative cos x. Integrating this, we're going to get negative sine x. Integrating this, we are going to get positive cos x, because this is a negative. If you are integrating it, it will be negative cos, but since there was a negative sign, now it becomes a positive. Then we're going to multiply this to this term, this one to this term, and this one to this term. So integral of x squared sine of x is the same as negative x squared cos x. This will be positive 2x sine x, then plus 2 cos x, then plus c as that. 2 cos x, then plus c. Let me just write it down here. Plus 2 cos x, then finally plus c, and that becomes the answer, this one.